Example 4. 3 gears are arranged as shown in the figure. Find angle theta rounded to the nearest degree. All right, so you can see in the picture we have 3 gears, a green one, a pinkish reddish one, and a blue one. Okay, the angle theta that we're looking for, sorry, it's not the best picture, but that angle is right here, and I'm going to put it in red so you can see it better. Okay, we're trying to find the measure of this angle based on the information that we've been given. Okay, you can see a triangle in the illustration. Okay, so that's the triangle we will be working with. Okay, we are given one of the angle measures here. We are told that this particular angle right here is 38 degrees. Okay, and then we're given some lengths. Okay, now these lengths are not part of the triangle that they're pointing out. They're actually the radii of the gears. So if you look at this, the distance, the radius of this blue gear is 3.6. Okay, we're not told the units. Okay, and that's okay. Okay, we're just assuming that whatever the measure is, it's consistent throughout the problem. Okay, so we know that this radius has is 3.6 units. Okay, for the pinkish reddish gear, the radius is 1.6 units, and then for the green gear, its radius is 2.7 units. Okay, so that's what we know. Okay, again, the distances that we are told are just radii of the gears. Okay, so how can we use this information? Okay, well, we can use the radii to figure out the side lengths of the triangles. Okay, so for example, watch where my cursor is. I can figure out this side length right here. Okay, because this side of the triangle, okay, it starts right here. Okay, and you can see here's the green radii, and then it immediately connects to the red gear. Okay, so this distance is going to be the red radius. Okay, so if I add the green radius to the red radius, that will give me this side of the triangle. Okay, so let me do that. We're going to do 2.7, which is the green radius, plus the red radius, which is 1.6. Okay, if you add these guys up, you're going to get 4.3. Okay, so this side length right here of the triangle is 4.3 units. Okay, we can do this again, if you follow my cursor, to this side. Okay, because the red or pinkish gear is touching the blue gear. Okay, so we can look right here. Here's the red radius. Okay, and then we can add on the blue radius, and then that will give us this other side of the triangle. Okay, so we're going to go and do that. So take the red radius, which is 1.6, add the blue radius, which is 3.6. That is going to give us 5.2 units, okay, for this other side of the triangle. Okay, unfortunately, we cannot do this for the third side, because if you look at it, okay, if you see where my cursor is, yeah, you travel the green radius and you can travel the blue radius, but there is a gap in between, so we can't figure out the length of this third side. Okay, so what we do know at this point, okay, when we look at this, we have two of the sides and we have one of the angles. Okay, so let me use a different color to kind of highlight this here. If I'm marking on this, because if you're trying to determine whether you have, side angle side, or if you have angle side angle or whatnot, you have to go in a consistent direction. Okay, you have to write down what you're given, then what's next to it, then what's next to that. Okay, so again, if we start at the top here, we have an angle, we have the side next to it. Okay, we don't know this angle theta, that's what we're looking for, but we have the next side. Okay, so that's our favorite wordy dirty that keeps coming up. So remember, we don't use this bad word. Well, yeah, we don't use it. We go backwards. Okay, so you can say I have a side, and an angle. Okay, so this is going to be side, side, angle. Okay, this is going to be law of sines, because it is not all sides and it's not SAS. Okay, you only use law of cosines for SAS and sides. Okay, so again, we have side, side, angle. Okay, this is the ambiguous case, but you can go through it later on your own time and figure out that there's only going to be one possible triangle here. Okay. All right, so let's go ahead and start labeling this triangle. Okay, put like the A's and the B's and the C's on it so that makes it easier. I'm going to call theta angle A, so that means the side across from it is side length A. I'll just take this blue one and make it angle B. So this is going to be angle B. So that means if I go straight across from angle B, this is going to be side length B, which is the 4.3. And then this orange angle right here, this is going to be angle C. Okay, if I go straight across from it, the 5.2 is going to be side length C. Okay, it did not matter which one you called which. Okay, what matters is once you place an angle, once you call it some letter, if you go straight across to that side, it has to be named with the corresponding lowercase letter. Okay, so let's see what we need to use. We know we're doing law of sines, so is it going to be the equation with the A's and the B's, or the A's and the C's, or the B's and the C's? Okay, well, we're trying to find angle A. Okay, we need to figure out what angle A is, so at some point we're going to have to bring in the sine of A over A. However, we don't know that right now. We can't use this at all because we don't know angle A, and we also don't know side length A. Okay, so we're going to have to start by using the B's and the C's because we know more information about those guys. So I'm going to go ahead and say sine of B over B is equal to the sine of C over C. Okay, when I look at this, this is going to work for me because I know angle C. Angle C is 38 degrees. So I've got this covered. I know side length C and I know side length B. This is going to allow me to solve for angle B, and then I can go from there. Okay, so here we go. Sine of B, we're going to have to leave it as that because we don't know angle B, but we know that side length B is 4.3. Okay, that's got to equal the sine of angle C, which is 38 degrees, over side length C, which is 5.2. Okay, by solving this, we can get angle B. Okay, so we have one fraction equal to another, so we can cross multiply. Okay, so this times this has to equal this times this. Okay, this is going to tell us that 5.2 times the sine of B is equal to 4.3 times the sine of 38 degrees. Okay, on the right side, that is just going to be a number if you pop it into your calculator. On the left side, we're multiplying the sine of B by 5.2. We need to isolate the sine of B. We're after angle B, so the first step in the process is isolating the sine of B. Okay, so let me write this out. We are after this guy. Okay, so first thing we need to do is divide off the 5.2. Okay, on the left side, the 5.2's will cancel, leaving me with the sine of B. Okay, I'm going to go to my calculator and see what this equals. Okay, make sure you're in degree mode. So I've got 4.3 times the sine of 38 degrees. That is the numerator. And then we need to divide by 5.2. Okay, so this is the nasty decimal that the sine of B equals. So I'm going to put 0.509 1046. You need to use the full decimal expansion here for accuracy, 815. Okay, we're trying to solve for angle B. Okay, so to do that, we're going to have to take the sine inverse of both sides. Okay, so let me set this up. Okay, and then we'll put it in the calculator and see what we get. So we're going to get the sine inverse of the sine of B is equal to the sine inverse of this decimal. On the left side, the sine and the sine inverse will cancel, leaving you with angle B. Okay, so this is what I need to go punch into the calculator. This is going to give us angle B. That's not the final answer, but it will definitely help us get there. All right, so let's go to the calculator. We already have this decimal in here, okay? So all we need to do is take the sine inverse. Okay, so I'm going to do, make sure you're in degree mode. Sine inverse, I'm going to do second negative sign here. That will bring up the previous answer, or just retype the decimal but use the full decimal expansion. Okay, so here is the angle. This is angle B, 30.604 21141 degrees. Okay, that is the measure of angle B. Okay, so where do we go from here? Okay, do I set up another law of sines equation with angle A? Because remember, we're trying to find angle theta, which we have called angle A. Well, we don't have to. We don't have to make it that complicated. Now that we know angle B, we also know angle C. So we know the angles in a triangle have to add up to 180 degrees. We can just do some simple subtraction and we're going to be done. Okay, so we know there's 180 degrees in our triangle. We have to subtract out angle C, which is 38 degrees, and we have to subtract out angle B, which is this mess. And that's going to give us the measure of angle A, or angle theta. Okay, so let's do it. 180 degrees minus 38 degrees minus, I'm just going to call up the previous answer or just retype it. Okay, here's the measure of angle A, or angle theta. Okay, so I'll go ahead and write this whole thing out. This is 111.3957886 degrees. Okay, the directions say to round to the nearest degree. Okay, so at this point we can say that angle theta, which is angle A, it is approximately 111 degrees. Okay, we are done.